4. And as always, we use ratio test. AN is what you're adding. Therefore, AN plus 1 is negative 1 to the n plus 1 power x to the 2n plus 2. No, it's just 2n, sorry. Yeah, 2n plus 2. And then square root of n plus 1 plus 1, 2 to the n plus 1. We then take the ratio. Capital R is the limit of n going to infinity of an plus 1 divided by an, which is, we first ignore the negative 1 to any powers because we have the absolute value. And then we take the two fractions and do keep change flip. So this is kept. Then the division is changed to multiplication, where the fraction is now flipped. So you have square root of n plus 1 times 2 to the n power divided by x to the 2n, absolute. Okay, and then the limit n going to infinity of x to the 2n plus 2 divided by x to the 2n. Okay. Then this times, I think I want to pair 2 to the n divided by 2 to the n plus 1. As before, having the same base is easier to simplify, and then you have radical n plus 1, radical n plus 1 plus 1. And then we can apply the exponential rules that exponents subtract when you're dividing the exponential forms. So 2n plus 2 minus 2n will cancel the 2n's. It will leave you with just x squared. N minus n plus 1 will give you 2 to the negative 1 power. And I'm not putting any absolute values there because x squared is always non-negative and 2 to the negative 1 is positive. So the only, and this is positive as well, so there's no need for any absolute value now. And I guess the only question left is that, what's the limit of this part? What do you think?
1.
It should be 1. Okay. This limit should be 1. Now, roughly the reason is that square root of n and square root of n plus 1 is the leading term of top and bottom, right? So you're really asking what's the limit of square root of n over square root of n plus 1. But then this is the same thing as square root of n over n plus 1. And we know that n over n plus 1 has limit of 1, right? So the limit is square root of 1, which is 1. So we know that that's 1. So that's like the rough explanation, which I don't really care if I'm grading, but if you really want to know the rigorous way of proving that's 1, here's a way to do it. Limit. You have square root of n plus 1 over square root of n plus 1 plus 1. You divide top and bottom by square root of n. Well, that would mean that you divide square root of n by square root of n, that's 1. 1 divided by square root of n would be 1 over square root of n. And they're both divided by square root of n. And then you say, well, square root of n plus 1 over square root of n is same thing as square root of n plus 1 over n. And you can split the fraction into 2. You get n over n, which is 1. 1 over n, that's just 1 over n. So that's what you get. So once you replace this one by square root of 1 plus 1 over n, then you can clearly see that 1 over infinity, this will be 0. This will be 0. 1 over n also is 0. So you have 1 over square root of n. 1 over square root of 1 is the only thing that's left, which gives you 1. So that's what you will do if you want to argue rigorously. But anyways, in whatever way you do, the answer will come out to be 1/2 x squared. Okay. So therefore, when do we know that this series converges? When it's less than 1. Right? So when this is less than 1. Let's figure out when that happens. So we see that x squared has to be less than 2. Right? When does this happen? When x is less than? Square root of 2, or bigger than? Negative square root of 2. So when x is between these two values, we know that that's true. And now we have two boundary values that you have to do. But however, see, when you plug in these boundary values, whether it's plus or minus right equal 2, here's what I want to say. If x is equal to plus or minus right equal 2, then x to the 2nth power is same as x squared to the nth power. Right? And then whether it's plus or minus square root of 2, squares takes away the negative value, so you get square root of 2 of 2. What's that? Square will cancel the square root, right?
It's just 2.
2 to the n, that's what you get, right? So because whether you plug in negative radical 2 or positive radical 2 in here, you get the same expression. Let's just do them both at the same time. So for x equals to plus or minus square root of 2, when this is plugged in here, you get summation of n equals to 1 through infinity of negative 1 to the nth power, 2 to the nth power. We just figured out that x to the 2n would be 2 to the nth power, over square root of n plus 1 times 2 to the nth power. So these cancel. And you have summation of n equals to 1 through infinity of negative 1 to the nth power of this thing. Now, does this converge or diverge?
Oh, that diverges.
Diverge. Because it's less than 1.
No, convergent.
Why does it converge? It converges. Why?
It will be, so you do the absolute value will be 1 over square root of n, so that's less than 1 over n.
But p is 2.
Oh, wait.
P is, where do you see 2?
P is 1.
Yeah.
No,
P is
no,
1.
you know, P will be
No,
1/2.
n.
No, what does this do? Negative 1 to the nth power.
Alternates.
Alternates. What do we use?
Alternating series test.
Alternating series test. So we are going to apply alternating series test.
Oh, convergence, because you set it to
So
0.
first, limit of n going to infinity of the absolute value, that gets rid of this, so you're really just taking this part that's equal to 0, right?
Mm-hmm.
And then absolute value of an plus 1 will be just get rid of this one because absolute value, and then you're replacing n by n plus 1. But that's definitely less than 1 over square root of n plus 1, because what happened was you decreased the denominator, therefore overall the fraction is bigger.
Right.
Going from here to there was a decrease in the denominator, which makes the fraction bigger, and that's absolute value again. So you do have this phenomena where you're jumping back and forth, where the jump sizes are becoming smaller and smaller, and it's going to 0. So eventually it has to be stabilized to a single value. All right? So by AST, it converges. So what's the answer? Answer is the interval of convergence is negative radical 2, which bracket? Yeah, square bracket for both cases, right? What's the radius? Radius of convergence is?
Root 2.
Root 2, yeah. See, the radius of convergence is root 2. It's not this number because the left side has a square. You have to be careful, okay? If you take, see, this is the same thing as saying that absolute value of x is less than square root of 2. So you can view it that way, but it's much safer to get the interval convergence and then b minus a over 2. That's the radius. Yes?
The only way of proving that an alternating series is convergence or divergence is by using the alternating method, right?
No, the question is, when you see an alternating series, do you always use alternating series test? No, sometimes you can just take the absolute value and show that one converges. In our case, that's tough luck. This doesn't converge absolutely because this is like the p series with p equals 1/2, right? You can use limit comparison with respect to 1 over square root of n to show that the absolute value does not converge when you add them up. So yeah, but if your absolute value converges, then this thing converges without having to check individual cases, these two items.